I'm going to attempt to run these two LED lights off of 120 volt AC and just plug them straight into the wall socket. Here, I'm going to cut the cord off this old heater that doesn't work anymore. This should work nicely, I hope. Now I'm going to solder these two LED diodes in reverse order, so current will pass through one, lighting one at one time and then the other at the other time, but never both at the same time. But in hopes that both of them together will actually allow the circuit to be created and light one. One will be lit with the positive side of the voltage, the other with the negative. Doing a little simple math on Ohm's law, I took 120 volts and divided it by 20 milliamps and came out with 2.400, or in other words 2400 ohms. And I didn't have one that big, so I got a 2700 ohm resistor. We'll see if this will work. Honestly, I don't know. Alright, we're all soldered up. You know, I really don't believe positive and negative terminals matter on this application, but we're about to find out exactly what matters. Safety, I've tied it to a poorly conducting wood chair and added an extension cord so I can plug it in at a distance. Now I have three different possible hypotheses here. One is that the LED lights will explode. The other is that it'll trip the breaker in the main. Last but not least, the one that it'll actually work. So here we go. Oh, well, I'll be damned. Smoking, but it works. Looks like my 1/4 watt resistor got hot and I started to catch fire, which tells me it was pulling more than 1/4 of a watt. Possibly by upping to a 1/2 watt resistor may fix the problem, or even a whole watt should definitely fix the problem. And then my low power usage LED Christmas lights will actually work and doesn't require a rectifier or transformer to drop the voltage and convert it to DC. And from what I can see, this is the most efficient way to use electricity for Christmas lights. So I found a 5600 ohm resistor, 1 watt resistor, which is double the ohms that I need, but it works. You know, the human eye can only see about 30 frames per second if this were a camera. DC current is only at 60 hertz, which means it only blinks 60 times per second, which is twice as fast as what the human eye needs to see. So every time one of these turns on, the other one is off, and then when that turns off, the other one turns on. So it makes it look like they're both on at the same time, but they're not. One seems a little more dim than the other. I'm not sure why, but it's interesting. Here it is. I have two tiny little 20 milliwatt LEDs run off of 120 volts AC. I personally believe that you could run at least about 1500 LEDs like this off of one single outlet plug-in. And not to mention, you're actually using both sides of the sine wave, which doubles the amount of lights that you can actually use with AC current because you're using every single bit of the wave. Make a long story short, if I could use those two LEDs and that tiny little resistor and put them all together in one small tiny little unit, I could do about 750 of them, which would make 1500 LEDs, which is one kick-ass set of Christmas lights. My math could be